Hello friends, so in this session we will study electrovalent bond or ionic bond. This ionic bond is also called as the polar bond. So when this is any element which have a 1 valence electron, this is the element which having a 7 valence electron. So what happens? One electron is shared by, this is given by, it is transferred by this from A to B. So on transferring, this will lose one electron, so this becomes a cation, and the B will become anion. Then when this positive charge of cation and negative charge of anion, so they will come closer each other, so they will form a one bond, and this bond is called as electrovalent bond. So they will create one force of attraction. This is a electrovalent bond, or you can say this is the electrostatic force of attraction between cation and anion, and this is the compound formed by ionic bond. So what is the definition? So an ionic bond is defined as the electrostatic force of attraction between cation and anion. These two are oppositely charged ions, and these are produced by the transfer of electrons. This means electrovalent bond is not possible between similar atoms. So one atom must be electropositive in nature because of loss, they are losing electron, and second must be electronegative in nature because they are gaining electrons. So what is the nature of this ionic bond? So since they have electrostatic force of attraction and they are held together by lines of force of attractions, and since this bond is non-directional, means it is spreading these lines of force in equally in all directions. Let us take example of NaCl. This is the sodium, this is the cation, and this is the Cl. So we can see the force of attraction from positive to negative. These are force of attractions, and this force of attraction we can reduce by using the polar solvent, like this is water. So water having the high dielectric constant, we can reduce the force of attraction between these two, cation and anion. So when water dissolve into this so NaCl is dissolved into the water, so water what will do, this will break these lines of force of attraction and they convert into ions like Na plus and Cl N minus. So we can see again these are the lines of forces from positive to negative. You can see it is spreading in all directions. That's it. That's why it is called as non-directional forces. So now we will study how to draw the structure of this compound. So this is sodium and Cl. So this is, we are writing the valence electron. It has one valence electron. Cl has 7 valence electrons. This will transfer electron. This becomes positive charge, and Cl will get negative charge. So we can write Na plus and Cl minus. We can put here minus sign. Similarly, this is the magnesium. Magnesium has 2 electron, 2 at 2. So it is giving 1 electron to fluorine, 1 electron to fluorine. This is 2 7 2 7. So after transferring, this becomes 2 8. This will be 2 8 2 8. So this is the magnesium fluoride. This is the drawing of Lewis. So Lewis dot structures. Similarly, sodium sulfide. So sodium has 1 more electrons in the valence cell, 2 at 1, 2 at 6. So on losing 1 more electron, give 2 electron to sulfur. This becomes 2 at 8, 6 to 2 6 plus 2 8, and this sodium plus and sulfide 2 minus. So this is written as a Na2 plus sulfide minus. Similarly, calcium oxide, you can see it has 2 electrons, it is giving 2 oxygen. So oxygen will get dye negative calcium. So ionic electrovalent dot is ionic compound. Lewis dot structure written like this. So these are the Lewis dot. Similarly, in case of aluminum fluoride, so there are 3 fluorine is there. So each fluorine having a 7 electrons. So each aluminum give 1 more electron to this different fluorine. So aluminum will get tri positive, and this is given 2 8. Each will get 2 8. So formula will be AlF3. Similarly, in case of sodium phosphide. So sodium have a single electron, phosphide have 5 electrons. So sodium 3, sodium will give electron to phosphorus. So phosphorus will attain the configuration 2 8 5 to 2 8 8, and sodium will 2 8 2 8. So this they are getting inert gas configuration. So it is Na3P. And AlF3, so AlF3 already we have written. So it is like this one. So let us leave it. Now what we are seeing, so each ion has a uniform electrostatic field of influence around it. Each ion, we are talking about each ion, so they have a electrostatic field of influence, so hence it is non-directional in nature. Each positive charge ion, they are attracting a number of negative ions around it. So thus number of ions depends upon its size or radius. Similarly, each negative ion, they attract a number of positive ions around it, and resulting into a 3-dimensional solid figure called ionic crystals. And this Ionic crystals is actually an overall electrically neutral geometrical three-dimensional pattern. So this Ionic crystal nothing but the neutral geometrical three-dimensional pattern. We will see this three-dimensional structure in the coming lectures. And this is also electrical neutral. For example, sodium chloride, we will see this is fully electrical neutral three-dimensional structures. Now, what are the conditions for forming the electrovalent or ionic bond? So, we will see the condition. One condition is the number of the valence electron. So, if the valence electron is 1, 2 or 3, so it will form cation. If the valence electron is 4 to 7, it will form say anion. The sodium, chloride, fluorine, so these are forming the monovalent elements. So, ClF will form anion while sodium will form monovalent cation. Similarly, calcium, oxygen, oxygens are the divalent elements. So, oxygen will form dianion and calcium oxygen form dication. Number of transfer is called electrovalency, but in transitional metals they lose more than one electron, or group 13 and 14, so they also lose more than one electron. So they show the different values of electrovalency. Since transition metal, copper having a +1 and +2 valency, and while iron having +2 and +3 valency. Similarly, lead in group 14 is +2 and +4, gallium group 13 +1 and +3. So there are different type of electrovalencies is also available for the metals. Why this? What are the reasons for the variable valency, electrovalency? One is the unstable configuration of the core atom. For example, iron having +3 +2 because it is unstable. Second is the inert electron pair effect, means NS2 NPX. So if you remove the X electrons, it becomes again inert. For example, it is happening in group 13, group 14. So group 13 having a NP1 electron and group 14 having the NP2 electrons. If you remove 2 electrons, the 2 electron is still there, NS2, and NS2 is there, then it is showing the inertness. So due to this is NS2, they are these group 13, group 14, they are showing the extra stability of the element. Okay, so this only happens when the N is less than or equal to 4. So that's why these transition metals or group 13, group 14 elements, they have variable electrovalency. Second is difference in electronegativity. So normally the difference between the electronegativity in two atoms are 1.7. This normally we are taking. Then they will readily form an electrovalent bond. For example, sodium fluoride, For example, sodium fluoride. So electronegativity of sodium is 0.9 and fluorine is 4. It is non-metal, it is metal. So if you take the difference will be 4.0.9. So this will give you 3.1. So it is more than 1.7. So it will form electrovalent bonds. If you take example HCl having the electronegativity value 2.1 while the Cl is 3.1. So difference will be 3.5 minus 2.1, 1.4. So this will not form electrovalent bond. Why? Because this is less than 1.7. So this is the one criteria to understand what type of compounds can form. They can make balances, they can make electrovalent compound or not. Next is overall decrease in energy. Means in formation of this electrovalent bond, overall energy of this compound, that ionic compound must decrease. Energy is releasing from that compound. Why it is releasing? One criteria is the atom wants to get ionization energy of the atom should get lower value. Means if the atoms will give less amount of energy and they form cations, okay, so they will form the electrovalent compound. Take example, sodium, magnesium, aluminum. So charge is less, this charge is divalent, aluminum is trivalent. So aluminum will difficult to give the electrons, but sodium will immediately give electrons. So they will form ionic compound easily, while the ionic compound formed by the aluminum is difficult because it has to release 3 electrons. Even it is releasing 1 electron also, that is also difficult as compared to sodium. Because by releasing 1 electron from sodium, it will attain the inert case configuration, while aluminum has to attain inert case only if they will release the 3 electrons. So chance of formation of ionic compound in case of sodium is very, very high as compared to aluminium. Second case is the higher value of the electron affinity of the atoms. Means greater is the formation anion. Means if the electron affinity of the atom is very, very high, then it will form the anion more easily like the cation. Halogens form anion easily because they have the highest electron affinity in the periodic table. So hence monovalent species like anion, fluoride, chloride, bromide, iodide. So they are easily formed and most common, and these are most common. While the divalent and trivalent species are very difficult to form and they are rare. So and next in terms of energy is your lattice energy. So there ionic compound must have the high lattice energy. Means if the lattice energy will be high, so it will easily form the ionic compound. What is lattice energy? It is the amount of energy released when 1 mole of ionic solid is formed by close packing of gaseous ions. The gaseous ions will close pack, and if after packing, if it is a 1 mole of ionic solid, so on packing of 1 mole of ionic solid, whatever amount of energy released, that is called lattice energy. For example, suppose this is sodium ions, chloride ions, so both are in gaseous state, 1 mole, and they are forming the three-dimensional structure of sodium. This is the Cl, this is sodium, Cl, sodium, Cl. You can see the upper face, there are 4 Cl and there are 4 sodium. Down will be same. This face will be also same. Behind of this face, front face means back side, same structure is there. Means each 6 face having this type of structures. So when they form these three-dimensional structures, after formation of this three-dimensional structure, this becomes so ionic solid, and they will release some energy. That energy is called as the lattice energy, and this is the crystal lattice. So in this way, this is the lattice energy is released from this 1 mole of ionic solid. So these cations and anions arrange systematically in an alternating cation anion pattern, and this is called as a crystal lattice. And this process of clustering ion increases the force of attraction and potential energy decreases. For formation of ionic bond, condition must be satisfied. Lattice energy plus electron affinity must be greater than ionization energy, or we can say lattice energy must be greater than the ionic energy plus electron affinity. If it is greater than these values, then the compound must having a high lattice energy. And how we can calculate this lattice energy is calculated from the Born-Haber cycle. I think you have studied this one in thermodynamics. So this from this cycle we can calculate the lattice energy, in which the heat of formation of the ionic compound is nothing but the heat of sublimation, dissociation, ionization energy, electron affinity, and lattice energy. All these are experimental values. So while calculating this value, we find out the lattice energy also. So value of lattice energy is actually depend on the charge present of two ions and distance between them. Means it is following the Coulomb's law. So Coulomb's law, this is the formula. Force, electrostatic force is equal to 1 by 4 pi epsilon into K, and Q1 into Q2 divided by D square. What is Q1, Q2? They are the two oppositely charges. And what is D? D is the sum of the ionic radii of two ions. What is K? And K is the dielectric constant of medium. So this is the formula. So D we can write in terms of this, the radii means radii of the cation plus radii of the anion of whole square. Now if you see carefully, so this force depending two factor. One is the Q1 plus Q2. If it is very high, then the force of attraction will be very high. And if R plus R2 will is very small, again force of attraction will be more. So if charge will be high and distance between them is very high, so what will happen? The lattice energy will be also very high. It is based on this, because in this case magnitude of charge is very high, and in this case internuclear distance is very small. So small means the size of the ions should be very, very small. Then lattice energy will be high. So ionic size of like sodium and potassium. So ionic size sodium is how much? 95 picometer, while potassium is 133 picometer. So lattice energy of sodium chloride is greater than the potassium chloride. So experimental value is also true. The sodium chloride how much? 769, while KCl is 698. Why? Because NaCl having the greater strength of ionic bond. Similarly, magnesium oxide is more stable than sodium chloride. Why? Because Q1, Q2 it is 4 times. Magnesium die positive and oxide is being 4 plus 2. So 2 into 2 it becomes your 4 times. So we can say lattice energy is inversely proportional to the size of the cation or anion, or directly proportional to the product of the charge of the cations or anions. So we can see if you going down the group, what will happen? Lithium chloride, sodium chloride, potassium chloride is same, but the size is increasing. So when size is increasing, what will happen? so lattice energy will also decrease. Similarly, it happens also here. So it is flowing, size increasing. So lattice energy will also decrease. Why? Because size of the anion is from fluorine to iodine is increasing. So lattice energy decrease. If iodine to fluorine, size of the anion is decreasing. So lattice energy will increase. Similarly, lattice energy also increases when the charge also more. So here sodium is +1, this is +2, +3 and +4. So charge is increasing, so lattice energy will also increase. So we can conclude compounds having the high lattice energy means it is high stability, it has high melting point. High melting point means there are some compounds used as a refractory materials. Means if the compound having high lattice energy means they must having the high melting point also. For example, magnesium oxide, aluminum oxide. Next is your third point is they are low solubility in water because of the high lattice energy. Like if lattice energy is very high than hydration energy, then in that case barium sulfate is insoluble in water because their lattice energy is very high. So these lattice energy, high value lattice energy will cause these three type of factor: stability, high melting point and low solubility in water. So these are the application of lattice energy actually.